All right, we are wrapping up this idea of surface area. Now we're going to be looking at prisms and cylinders. Basically the non-pointy shapes. They got two bases, double bases, top and bottom. First, again, we're going to be looking at labeling. Then we're going to calculate the surface area. Surface area, which is basically the lateral plus, this time there's two bases, so we're going to have both bases. So let's start out with labeling. This is very easy. We got a radius of 4. Here it's 4, so we're going to go to our circles, and that's going to be 4. And this radius as well is the same. That's also 4. And then this is 7, so we know that this height here is going to be 7. Let's go and label that in blue. That's 7. Now the piece that might not be so obvious is this height here that wraps around the edge. And if you notice as I'm drawing this blue line, you say, oh, that paper there, or this top of the rectangle here, is the same as the edge that wraps around. And the edge of a circle is equal to 2 pi times the radius. Well, in this case, 2 times pi times 4 equals this, or in other words, simplified, that would be 8 pi. 8 pi. So that's also 7 over here, and 8 pi for the bottom edge as well of that rectangle. So there's the pieces, and those would help us calculate the area. Let's look at this one. So first thing I see is 28. 28 is all over the place. We got 28, 28, 28, 28, 28. Now this piece here is not directly obvious, but if you notice this bottom edge is 8 and this is 17, that means this is also 15 and this is also 17 and this is 8 here. 8, 15, 17 is a right triangle. And 17 is the biggest side, so that means that this side right here is going to be the corner or right angle. Now when I look at this shape, it looks like this is the right angle, so that means this piece here would be the longest side. If that's the longest side, that's 17. That means this is also 17. And this is a right angle as well. Well, this shorter piece, that's pretty easy to figure out. That's 8. That means this shorter piece here is 8 as well. This middle piece then is going to be our 15. That's the 15. Now that we have all these pieces labeled, oh, this would be 15 as well. 15, 15. That would help me calculate surface area by calculating each area individually. We're going to do that in the second half though. Alright, now we got this piece here. This 7.6 represents that apothem where we go from the center of a regular polygon out to an edge. So that's 7.6. And then the 11 is going to be the edges. So all these are 11, 11, 11, 11. So that's 11, 11, 11, 11. Oh, no, wait a second. Is that right? Yeah, it is. That is 11. And then the height, which is slightly longer, and it makes sense because this slide does look longer, is 13, all the way across on all these. So that would be our measurements for these ones. 7.6 down here for this other apothem. Let's keep on moving. Number 4 here. Oh my gosh. You gotta be kidding me. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. 999 nines. They're 9 all over the place. It's 9s everywhere. That was easy to do. Next. Ooh, alright. So we got a 15 and a 16. One edge is slightly longer than the other. It's kind of challenging to see exactly which one is slightly longer because this could be oriented either way. But it almost looks like this top piece here is slightly shorter. So that'll be 15, the other side will be 16. And then these short pieces are going to be 5, and 5, and 5. And that means this piece here is also going to be 15, and then the other edge, which is longer, is going to be 16. Inside here we got 5 by 16 as well. Alright, that wasn't too bad. Ooh, this one, it's like that pentagon one, except it's a hexagon now. So we got this apothem going from the center out to an edge, that's 8.7, and then each of the edges of this hexagon are going to be 10, which means each of the edges of these rectangles are also going to be 10. And the height of each of those is the 11. That's the height going up and down. Let's keep moving. We're doing really well here. Oh, find the lateral area and surface area of each figure. All right, now we're getting into it. Okay, so if I see this, I see 1, 2 triangles, and then 1, 2, 3 rectangles, and that's what I have over here. So these triangles, if you look at them, they have a 6, 8, and 10 for the measurements. So we got 8, 6, and 10. That means this is 6, 8, and 10 as well. And if I'm looking at these, there's a height for each of those rectangles. That's 4. So I'm going to make a height of 4 for each of those. We got 4, 4, 4. And now let's find the areas. Well, 6 times 8, which is our base and height, because I know these two are perpendicular. They make a right triangle. And the hypotenuse would be 10, the longest side. So 6 and 8 divided by 2. So the area of each triangle, area of a triangle is equal to 1/2 base times height. Well, in that case, that's going to be half of 6 times 8, or altogether 24. So this is 24, this is 24. Now let's find the areas of these 3 rectangles. Well, we got 10 by 4, that's 40. And 6 by 4, that's 24. And then 8 by 4, that's 32. So now all we got to do is add all those together. So the total is going to be equal to 40 plus 24 plus 24 plus 24 plus 32. Now we could simplify it if we want to. I'm not going to. But you can if you want to. Let's just keep moving. Oh, by the way, what's the lateral area? Ooh, so that was the total surface area, but how much of that is the lateral? Well, notice the lateral is the non-bases. This is a base and this is a base. So the lateral is not the 2 triangles there. So we would take out 2 of the 24s, and so the lateral area would be 40, 24, and 32, those ones that I underlined. That would be your lateral area. Let's get number 8. Maybe we can do this one a little more cleanly. Well, here's the lateral. Let's do this in different colors. So we'll do this in blue. The lateral is just this rectangle in the middle. It's not the base. It's because up here on top, this is a base, and this is a base. So let's go ahead and color code this stuff. So if I do tools, then we got fill. We're going to fill it with orange. I'm going to fill that one, fill that one. So we got bases that are orange. So those 2 bases are orange, and they have a radius. Well, the diameter all the way across is 14, so that means a radius is actually 7. And similarly here, this is 7. I like to use a radius. You can use a diameter for this, but I like to use a radius. The area of a circle is equal to pi r squared, which in this case is going to be pi times 7 squared, or if we simplify it even more, 49 times pi. So that's the 2 bases. And I have 2 of those. So it's 49 pi for this one up top, and 49 pi for the bottom one as well. So let's figure out this lateral area. Well, I know the height here is 8, so that's going to match up with this here. And I know that this line that goes around the edge of the circle on the top is the congruent to this line of this rectangle going across the top. So it's because it's got to connect to that entire circle. Not more, not less, but exactly it. And that circumference is 2 times pi times r, or pi times the diameter, which equal 2 times pi times 7, or 14 pi. So this height, or this length here, is going to be 14 pi. Well, if I were to multiply those 2 together, I'd have 8 times 14, or let's see, how much would that be? 112? I think so. Pretty sure. Yeah, it'd be 112. 56 times 2. So 112 pi is the lateral area. So the lateral is 8 times 14 pi, which winds up being 112 pi. Then we're going to add to that the base area. There's 2 of these circles, and each circle was in itself 49 pi. Now if we simplified all that together, we'd get 112 plus a lot of this, 98. What's that, 210 maybe? I don't know. But who cares? That's simplifying. You guys can do that. Calculators can do that. We don't need to. Total surface area. Next. Alright, a box. We love boxes because they are rectangles, and this one is actually two squares in rectangles. Just to be clear, notice that the lateral area this time is not the two squares, because two squares are congruent, but then these, actually, you know what? It doesn't really matter. Oh, this is confusing. Because of the way that a prism works, we don't know if the lateral wraps around one direction, if it's going around this way, or this way, or this way. There's three dimensions of rotation we could be doing there. We don't know which one. So screw that lateral area. Let's just find the total. The total. Well, I have a net here. Hopefully you guys saw that. And I'm going to label it. We know this is 7, 7, 7, 7 for the square. And these shorter pieces are 5. And that means that's 7 as well. And 7 and 5. So let's figure out these totals. We got 35 for these smaller rectangles. Ooh, I'm missing a rectangle. Did you guys notice that? There should be another one somewhere on here. That would be 35 as well. And then these big ones are 49. So those are the areas, and if we add all those together, we get our total. So our total this time is going to be 35 plus 35 plus 35 plus 35 plus 49 plus 49, 2 49s and 4 35s. Booyah. Next. Number 10. Ooh. Ooh, ooh, ooh. Well, let's start with the lateral area. In this case, it's very clear what the lateral area is. It's these rectangles going around the outside. Well, we know the height of those rectangles is 8. We also know that the edge of each of those rectangles is 12. So let's use that to our advantage. We got 1, 2, 3, 4, 5 12s, and then an 8. And they're all congruent. So that means I got 5 of these rectangles, and each of them is base times height. So it's going to be 8 times 12. So that's my lateral area. Now I also need to find my base. So let's go ahead and fill in those bases so we can see what we're really looking at here, base, base. Okay, now if we find the area of the base, we're going to be adding the area of the base, bases, I guess you could say, because there's 2 of them, is a pentagon. Now these pentagons can be split up in such a way that we can do triangles instead of pentagons. So let's do that. I'm going to go ahead and split this up into 5 triangles. Just to make this a little bit easier. And notice too that this is actually a, these 2 pentagons are congruent. So if I find one, I just got to multiply it by 2. That gives me both of them. Well, that apothem, this 8.3, that's going to help me a lot because this line here that I'm tracing over in purple, that's the same as this line here. And that's the height of each of these triangles. So that's 8.3. And then the base, we already know was 12 because that's the same as all the other bases. So for the triangles, or the total area of these bases, well, it's going to be 2 times the pentagons, which is going to be 2 times, now the area of the pentagon is 5 times the area of each of those triangles. So we got 2 times 5 pentagons times the area of each triangle is half, which is half base times height. And the base in this case is 12, and the height is 8.3. That's a lot. Let's say I did want to simplify this just a little bit. I could reduce or simplify the half and 2, then I have 5 times 12 and 8.3, and I got 5 times 12 and 8 here. So that's a little bit simpler. Well, I'm not going to do any more than that, because put these together and you got the total surface area. Next, number 11. So we got this triangular prism here. Notice that this piece in the middle, this is our lateral, and then these 2 triangles that I'm going to fill in with orange here. Let's go to Tools, Fill. We'll fill these in with orange. Those are the bases. So that's a base and that's a base. And it's actually kind of cool because they're 3, 4, 5 triangles. A clever pattern that we have noticed. There are 3, 4, 5 triangles, meaning that this other diagonal is 5 as well. So if I were to figure those out, we got 4 and a 3 and a 5, and this is 5, and this is 3, and this is 4. Notice that this net shows kind of the proportions here. If this is 4, it's going to connect to this edge down here. So that's also 4, and that's 4. And that means that this bottom piece, this is actually a square. It's 5 by 5. How do I know that it's 5 across? Actually, I don't, and it's not. Wow, I can't believe I made that mistake. It's 9. So that's 9, 9, 9, 9. So let's start with the lateral surface area. So it's going to be the 3 rectangles. And each of those is just base times height. So we got base times height plus base times height plus base times height. So the first one we got is 3 times 9. 3 times 9. And then the next one is 4 times 9. 4 times 9. And then the last one is 5 times 9. 5 times 9. So that's my lateral area. Now when I look at the bases, those are 2 triangles. So I'm going to have 2 times the area of a triangle, which is 1/2 times the base times the height. And in this case, that's going to be 2 times 1/2 times those bases are 4, and the heights are 3. Or vice versa, it doesn't really matter. But together, the lateral and the bases make our total surface area. Pardon me. Let's do another one. Ooh, trapezoid. All right, let's go ahead and put in some of this information that we have here. So first we got this altitude, which is 3.5. So I'm going to make a little dotted line here. It's perpendicular to these bases. And that's 3.5. I noticed that this long base on the inside is 7, so those are 7. And the short base is 3. These aren't actually drawn to scale, but hey, whatever. And then these pieces, this height wrapped around the outside is 6. That's 6, 6, 6, and 6. What about this one right there? What is that one? Well, that has to match this slanted piece. These two have to be congruent. And I know that slanted piece is actually 4, so that means this one has to be 4 as well. That's why they gave us that slanted piece. How do I know those have to be congruent? Well, if I were to fold this up, these 2 pieces have to match up with each other, which means that they got to fold onto each other. So that 4 applies to both this rectangle, which is going to help us find surface area, and the diagonal there, which we don't really need. Alright, so the lateral area. The lateral area is going to be across the middle here. So the lateral is those 3 boxes added together. So that's going to be base times height plus base times height plus base times height. Well, the base is going to be 4 times 6 plus 7 times 6 plus the last one is going to be another 4 times 6. Now if I were to look at these bases, let's go ahead and fill those in, just like we did with the other ones. Fill, boom, boom. Alright, so the bases, we're going to add the area of those to this. Well, the bases, there's 2 of them, so I'm going to multiply it by 2. And they're trapezoids. And the area of a trapezoid is 1/2 times the sum of the bases, base 1 plus base 2, times the height. Now, this height in this case, just so you guys are recognizing this, is not the 6. It's actually the height of the trapezoid, which is 3.5. So we're going to have 2 times 1/2, which really simplifies to 1. Then the 2 bases that we're adding together are 7 and 3, so that's 7 plus 3. And then the height of the trapezoid is 3.5. You add all that together, you get the total surface area. All right, let's look at number 13. We're doing great here. We only got 2 more. Okay, I went ahead and drew a net that went with this. It's a hexagonal prism. Hexagonal means 6 sides. That's why I drew a 6-sided figure. And then this net with the rectangles that make them. says it's 6 feet tall. So that's the height here. Now if I were to maybe group these together, that might help a little bit. Let's do that. We'll rotate this around. Whoa, that was cool. So it's 6 feet tall. So that means that's a 6, that's a 6. These are all 6s actually. And it's 9 feet on each edge. So that's 9, 9, 9, 9, 9 all the way around, which means these edges are all 9, 9, 9, 9, 9, 9, 9 all the way around. And then it says it has an apothem length of 7.8. That apothem is when we go from the center of our regular polygon out to the edge. And that's going to be 7.8. And that helps us, again, because now we can split this up into triangles. And those triangles can be used to find the total area of this hexagon. So let's fill in that hexagon just so we know what we're doing. So we're going to fill this thing. And we're going to fill this one down here as well. Alright, so what do we want to do first? Let's do lateral area. Lateral area tends to be our first step a lot of times. So we start with the lateral area. The lateral area. The lateral area is, again, not the bases, it's the non-bases. It's the part that wraps around. So that's got to be these other boxes here. Well, we got 6 of them. 1, 2, 3, 4, 5, 6. So we got 6 of those boxes, and each of those boxes has the same measurements. It's all 6 by 9. That was easy. That's our lateral area. Now let's add the bases to this. So when we're adding the bases to this area, that means that we're going to have 2 of them because there's 2 bases, and it's the area of the hexagon. The hexagon is broken up into 6 triangles. So the hexagon area is going to be equal to half the base times the height, 1 triangle times 6. So that's going to be 2 times 6 times the area of each of those triangles, which is 1/2 the base and the height. Well, the base of each of these triangles around the edge is 9. Okay, so we got a 9 in here. And then the height was that apothem height that they gave us, which was 7.8. There we go. This whole chapter is about using what you're given and plugging it into the formulas appropriately. It's very easy. Again, I didn't simplify. And again, this is your total surface area. Pretty sure, is that the last one? No, we got one more. Last one of the day coming right here. Prism is 2 meters tall. The base is a trapezoid whose parallel sides are blah, 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 blah. The altitude of the trapezoid measures 3.5 meters. Well, that sounds almost identical to this one. What's the difference? Well, it says it's 2 meters tall. And this one was 6 meters tall. You guys see that? It's got a 6 here, but it says 2. So it's the exact same as this one, except you replace the 2 with the 6 with the 2. So just look at this slide. It's the same picture, and it's saying that it's 2 meters tall. So this would have been a 2, and it's meters instead of yards. So just something to think about. I'm not even going to solve it because we already solved it. Just replace your 6s with 2s. And that's all she wrote for today. Thank you and have a good night.